Hello friends, welcome to my channel. Let's have a look at problem 2419, longest subarray with maximum bitwise add. In this video, we're going to share a solution based on finding the largest subarray with all its elements being the capital M, which is the largest element in the original array nums. So first, we'll read through the statement to digest the problem requirements, and then we do a simple analysis on the properties of the bitwise add operation, and finally we share the code. So this problem is marked medium by Leetcode. However, if we analyze the properties of the bitwise add, so this problem is rather standard. So first, let's look at the requirement of the problem. So we are given an integer array called nums of a certain size, say m. So we consider a non-empty subarray from nums that has the maximum possible bitwise add. So here the bullet point explains the requirements in detail. So we are required to return the length of the longest such subarray. So a subarray is a contiguous sequence of elements within an array. So this is the main statement. So there are two examples given. So the output for example 1 is 2. So actually we will know that this array corresponds to the 3. So because 3 is the largest element in the nums array, so there are a continuous piece of 3s, so their length is 2. So in this example 2, so the output is 1. The reason is that the maximum value of this nums array is 4, and so there is only one 4 here in consecutive fashion, so the output is 1. So we will analyze and digest this more. So the constraints or additional assumption for this problem are the following. First, the length of the original nums array is bounded above by 10 to the power 5. So this first constraint actually defines the problem size. And secondly, it's about the range of elements in the nums array, which is not negative and bounded above by 10 to the power 6. So with that said, we can look at the analysis. So actually the method specifies what we will do. So here the observation is basically the following. So for two non-negative integers a, b here, so there holds that the bitwise add of ab is less than or equal to the minimum of the two. So actually this is very easy to understand due to the definition of bitwise add. So at each position of the binary representation of AB, so bitwise add will pick the smaller bit, right? So for example, we have 10, that is 1010, and we have 12, that is 1100. So their bitwise add is 1000, right? Which is 8, so which is strictly less than the minimum of 10 and 12, that is 10. So in fact, so if A equals B, so certainly we have A add B equals A and equals B. So if we further digest from this observation, so notice that if A and B are not equal, then we know A and B is less than or equal to minimum of AB, but the minimum will be strictly less than the maximum of A and B because they are different. So in other words, A and B is strictly less than the larger if they are not equal. So then actually we can recap for the task in this problem. So if we let capital M to be the maximum value of nums, then the task is to find the longest subarray with all elements being M. So here we are talking about subarray, right? So this is actually a routine task now. For example, in example 1, so this is a nums. So the largest value is 3. So the longest subarray contains all 3's are 3, 3. So the return is 2. So this is actually the main task and what we are going to do. So before we write the code, here is an extension. So we want to draw your attention to compare this problem to a Leetcode problem 2411. So the problem 2411 is concerning the bitwise OR operation. So it's actually good to try this problem or find an analysis in our channel for this bitwise OR variant of the current problem we are looking at. So with that said, now let's look at the code. So actually we can do this in one pass or in two pass. So let's first write a solution using two pass. So the two pass because first we want to traverse the nums to get the maximum. So let me do this. So I'm going to say m is the max of nums. So if we regard this as a one pass, so we get this m. So next, what we're going to do is to get the longest consecutive m's, right, capital M's in this nums array. So for this, actually we can initialize a result variable. So it's going to be the global max of the length of consecutive capital M's, and the current will store the length of maximal consecutive M's in the current piece. So then we just need to do a for loop, right? So for number, so for y in nums, so if y equals the capital M, then we're going to increment the current by 1, right? So otherwise, so what we're going to do is that, so we reset the count or the current to be 0, right? So then each time, so we're going to consider the max of this result and the current, and finally we just need to return the result. So this is actually one implementation. So let's how check. Yeah, it passes the first example. Now let's look at generic case. Yeah, it passes all the generic cases. So actually this implementation do the check for the result every time when we look at a number. So actually we can slightly improve on this to reduce this number of checks. So let me write another solution format. So let me copy this one first, and then we will use this one as V1. So now let's write. So this version is still a two-pass solution. So the one pass is to get the max, so the max of nums, and then we want to give a detailed analysis. So we're going to use a result to record the global consecutive length, and then we're going to initialize the current to record the current consecutive M's. Then we want to make some detailed analysis. So for I in range, so length nums. So here actually we can write this to be n, right? So then what we are going to do is that so if we regard this as two pass, this is also okay, right? So but that's not very essential. So for I in range n, so what we are going to do is if check for I equals 0, what we are going to do is that if nums I equals this capital M, then we're going to set the current to be 1, right? Otherwise, so if nums I equals M, then we consider two cases. If nums I minus 1 equals M, in other words, we are looking at a consecutive case. So we are going to increment this current by 1. Otherwise, we need to start over again because nums I minus 1 is not this capital M. So then we need to make a comparison. So result and current, and then we are going to reset current to be 1. In this one means the current nums I equals M, right? So this is one case. Otherwise, So if nums I does not equal to m, then we're going to make a comparison first, and then we're going to reset current to be 0. And finally, we want to treat the case if I equals n minus 1. So in this case, we need to make a comparison again. So that's the result and the current. And finally, we return the result. So this is another format of solution. But let me delete this comment. Maybe some people say 3 paths or something. So yeah, let's actually first do a check. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. So now let's have a look at another solution format, which might be regarded as a single pass. So let's call this version v2. So here, what we are going to do is that we not compute the length. So first, I'm going to initialize a result variable to be 0 to get the global length, and we are going to set current to be the length of current consecutive largest values. So current max will be 0. So originally we do not know, right? Then we are going to iterate for y in nums. So here in. Then what we are going to check is that if this y is greater than the current max. So if so, we want to record the consecutive y's, right? So what we are going to do is that current max to be y, and current equals 1, and then we set results to be 1. So this is one case. Another case is that if y equals current max, and then in this case we are going to increment the current by 1. So this is another case. Otherwise, what we're going to do is that, so we're going to set the current to be 0. So in other words, if we see the y is less than the current max, right? So with that done, so each time we're going to make a comparison. So result and the current, and then we just need to return the result state. So this is another solution format. So let's look at a check. Yeah, it passes all the one example. Now let's look at generic case. Yeah, it passes all the cases. So I guess that's about it for the solution to this problem. So basically, the point is to notice the property of the bitwise AND. Then we reduce the problem to be finding the longest subarray with all elements being the maximum value of the original nums array. So with that said, I guess that's about it for this video. Thank you very much.